This is the tallest church in Europe. It took 144 years to build. It's called the Sagrada Família, and a few days ago, it was finally finished. But the story of how it got here is far stranger than it looks. In 1936, a mob of anarchists stormed an architect's workshop in Barcelona. They smashed plaster models to dust, burned the blueprints, and torched every note and sketch they could find. And when they were done, they were certain of one thing. They had wiped Antoni Gaudí's impossible dream off the face of the earth. For good, they were wrong. Just days ago, after decades of feuding, zoning scandals, and billions of euros, this impossible project finally crossed the finish line. The main structure is done. The towers are up. The world's most famous never-ending construction site, a project that dragged on for nearly a century and a half, has at last reached its end. But here's a simple question worth sitting with. How do you finish the most complicated building ever attempted when the architect has been dead for 100 years, and every last instruction he left behind was turned to ash and plaster dust? The answer is buried in a mathematical puzzle, so strange it took experts more than 50 years to piece back together. And somewhere in that detective work, they stumbled onto a single detail that architects are still arguing about today. One that raises a deeply uncomfortable question. Is the Sagrada Familia we just finished even the right one? What if the engineers, trying to crawl inside the mind of a genius, got it catastrophically wrong? And why does finishing this church right now threaten to wipe an entire neighborhood off the map? Today, we're dissecting this building. We'll break down the geometry that broke the rules of architecture, run the numbers that are honestly hard to believe, and show you how a project dreamed up in the 19th century forced its builders to invent the technology of the 21st. To understand the scale of what was lost in 1936 and the genius of what's standing today, we have to rewind. Most people assume the Sagrada Familia was Gaudí's baby from day one. It wasn't. It started life as a completely ordinary, frankly boring neo-Gothic church designed by a different architect, Francisco de Paula del Villar, back in 1882. But Villar got into a fight with the project's backers over the cost of materials and stormed off. The next year, the job landed on a young, relatively unknown Gaudí, and he did something that horrified his conservative clients. He threw out the old plans entirely. He decided to build something the world had never seen, a giant Bible written in stone. The trouble with Gaudí was that his ideas weren't ahead of their time by decades. They were ahead by centuries. He despised straight lines and sharp corners. The straight line belongs to man, he said. The curved line belongs to God. His design had no flat walls, no standard load-bearing columns. The entire building was meant to grow, bend, and branch, like a living forest made of stone. But how do you build a stone forest as tall as a skyscraper without the whole thing collapsing under its own weight? For centuries before Gaudí, architects relied on massive buttresses, those giant external props you see holding up Notre Dame in Paris, to keep the walls from splaying outward. Gaudí called them architectural crutches. He wanted a building that could hold itself up, so he invented something brilliant, an analog design method. He built what's called a hanging model. Gaudí strung ropes from the ceiling and tied tiny bags of lead shot to them. Gravity pulled the ropes into gentle sags, perfect arches, and here's the physics. A hanging rope is in a state of pure tension. Now watch closely. Take that exact shape, flip it upside down, and build it out of stone, and you get an arch in a state of pure compression. No props needed. Every line of force runs cleanly down into the ground. Gaudí didn't need to crunch complex structural equations. Gravity did the math for him. He'd simply place a mirror beneath the ropes and look into it, and there, reflected back, was his future building. By the end of his life, Gaudí had become a true fanatic. He stopped taking other commissions, moved into the construction site itself, and slept in a tiny room surrounded by his drawings. He wore rags and poured his entire personal savings into the church. He knew perfectly well he'd never live to see it finished. And when reporters asked why it was all going so agonizingly slowly, he gave his famous answer, "My client is in no hurry." In 1926, lost in thought, Gaudí stepped in front of a tram. Because of how shabby he looked, he was mistaken for a beggar and taken to a hospital for the poor, where he died. By that point, the Sagrada Familia was barely 20% complete. Just a single tower of the Nativity facade had been built. But Gaudí always knew the project would outlive him. So he left behind incredibly detailed plaster models, built at 110 and 125 scale. Think of them as his analog 3D renders, a physical database. He'd encoded the church's impossibly complex geometry into these plaster shapes. And then came 1936, Civil War. The anarchists, the fire. The building's source code was reduced to thousands of broken shards scattered across the floor of a burned-out workshop. For years after the war, construction sat almost completely frozen. Many of the era's great architects, Le Corbusier among them, argued the whole thing should be abandoned, left as a ruin, a monument to what might have been. Reconstructing Gaudí's vision seemed flatly impossible. Then, in 1979, a 26-year-old architect from New Zealand named Mark Burry showed up. He was handed an almost insane assignment. Take the shattered fragments of Gaudí's plaster models and try to figure out what just one of the windows was actually supposed to look like. As Burry studied the plaster, he made a stunning mathematical discovery. All those wild, flowing, organic shapes Gaudí loved weren't the random flourishes of a sculptor following his gut. They were built on strict, almost crystalline geometry. Gaudí had been using something called ruled surfaces. In geometric terms, hyperboloids, paraboloids, helicoids, and conoids. It sounds like a spell muttered in Latin, but the idea is incredibly elegant. You know Pringles chips? That curve is a paraboloid. The cooling towers at nuclear power plants? Those are hyperboloids. And here's the magic property of these complicated curved surfaces. You can generate every one of them using nothing but intersecting straight lines. Which means no matter how strangely a column or a vault in the Sagrada twists and curves, hidden inside it is a grid of perfectly straight segments. For Mark Burry, this was the key to the cipher, because if a shape can be described by an exact mathematical rule, then it can be rebuilt. Even if you're missing a chunk of the model, you can calculate exactly where the line was headed next. But there was a problem. In the 1980s, the team tried to move these calculations into the first generation of computer software. And the standard architectural programs of the day simply couldn't handle it. The moment engineers tried to model dozens of hyperboloids intersecting at once, the software froze or spat out errors. It was just too much, so the engineers made a radical decision. They walked out of the world of architecture entirely and turned to the aerospace industry. They started using CATIA, an absurdly powerful parametric modeling program. For context, CATIA is the software Boeing and Dassault used to design complex aircraft, fuselages, and turbine blades. So sit with the absurdity here. To finish a Catholic church that was started by men who got to work on horseback, engineers had to reach for the same software used to simulate the aerodynamics of fighter jets. It changed everything. The engineers translated the broken plaster into digital code, and a construction project that had been crawling along for decades suddenly started to accelerate. Today, the Sagrada Familia is a miracle of raw computing power. It would have been physically impossible to finish without massive databases, 3D printing, and computer-controlled machine tools. Let's look at the numbers, just to grasp the scale of it. The footprint of the church is about the size of a soccer field, but it grows vertically. The central tower of Jesus Christ, the crowning peak of the whole structure, rises 172 meters into the sky. That makes the Sagrada Familia the tallest religious building in Europe, edging out Ulm, Münster in Germany. Why 172 meters and not 180 or 200? Gaudí was adamant about this. The highest natural point in Barcelona, the hill of Montjuïc, stands at 173 meters. And in his mind, The work of man had no business rising higher than the work of God and nature, so he left a 1-meter margin out of respect. The whole building rests on an intricate forest of 56 giant, branching columns. The total weight runs into the hundreds of thousands of tons, and there isn't a single identical stone anywhere in it. Every block is unique in shape. In the old days, a stonemason might need weeks, sometimes months, to carve a single complex geometric piece. Today, robotic mills do the work. First, architects 3D print the piece to check how it fits against everything around it. Then the digital model gets sent to a CNC machine where giant diamond saws carve the exact shape out of granite, basalt, or porphyry with jeweler's precision. The construction site has become a giant, high-precision assembly line. But even with supercomputers and robots, the team ran headfirst into an engineering nightmare when it came time to raise the 6 central towers. How exactly do you raise 170-meter stone spires in the dead center of a densely packed city? Up at that height, the winds are brutal, and a tower made of stacked stone needs to be incredibly strong. The classic solution would be to pour a thick reinforced concrete core inside, but that would make the towers far too heavy, and the foundation, laid back in the 19th century, simply couldn't bear that kind of mass. So the engineers found another way, using a technique called press-dressed stone. Instead of stacking blocks one by one at a height of 100 meters, risking workers' lives in the process, they figured out how to assemble enormous panels down on the ground inside dedicated hangars. You take several massive stone blocks, you drill holes straight through them, then you thread thick steel cables made from a high-strength alloy through those holes. Hydraulic jacks tension the cables with incredible force, and the ends are locked into place. And here's what happens. The stones get squeezed together so tightly that the entire panel, all 20 tons of it, becomes a single solid monolith. It turns incredibly rigid, able to shrug off any wind load or earthquake. And crucially, it needs no heavy concrete core inside. Stone, laced together with steel tendons, holds itself up. Then a giant crane simply lifts the finished panel up and sets it in place, like a massive Lego brick. This one innovation is what let the team blow the construction speed wide open over the last 10 to 15 years, cutting the time spent working up at height by a factor of dozens. It sounds like the moment computers showed up, everything went smoothly. That's an illusion. Over the past 20 years, the Sagrada Familia has come to the brink of disaster more than once. Challenge number 1. The stone crisis. Gaudí originally built the church from a unique stone quarried from that very same hill, Montjuic, right in Barcelona. It had a particular sandy color and remarkable strength. But by our time, the Montjuic quarries had been completely exhausted. The original stone was gone forever. How do you finish a building when the raw material no longer exists anywhere on Earth? Using ordinary concrete would mean disfiguring the church. So the engineers had to become geological detectives. They took samples of the original stone and flew around the world, analyzing the color spectrum, density, and chemical makeup of rock in hundreds of quarries. In the end, to find the perfect match, they had to ship granite all the way from Scotland, from a quarry near Aberdeen. Today, the Sagrada Família is a geological mosaic drawn from across the entire planet. Stone comes in from Brazil, Iran, India, and France. At a dedicated facility outside Barcelona, hundreds of tons of rock are scanned and sorted by neural networks according to the faintest differences in shade, so that new blocks blend seamlessly with the ones laid down a century ago. Challenge number 2, the Tunnel of Dread. In 2010, the Spanish government decided to run a tunnel for the AVE high-speed train directly under Barcelona. And the tunnel's route ran barely 4 meters from the foundations of the Sagrada Familia's main facade. This was a moment of pure terror for the entire construction team. A massive tunnel boring machine, 12 meters in diameter, was about to grind through the earth beneath a building that weighs hundreds of thousands of tons. and has no rigid steel skeleton on its lower levels. The slightest vibration, the slightest settling of the soil, and the towers could crack. The Sagrada team installed thousands of laser sensors throughout the building, tracking any movement down to a fraction of a millimeter. The railway's engineers built a protective underground wall of concrete piles between the tunnel and the church. And as the drill crept past, the whole city held its breath. Mercifully, the sensors picked up no critical shifts. The church held. Challenge number 3, the big one, the war over the glory facade. Now we arrive at the most contested part of this whole story, the open question that right now has tempers boiling over in Barcelona. The scaffolding has come down off the central towers, but one piece remains unfinished, the main entrance known as the glory facade. In Gaudi's original vision, this facade was to be approached by a colossal grand staircase, a bridge, rising up and over the street below. There's just one problem. Over the 140 years it took to build the church, the city grew up around it, and the spot where Gaudí sketched his monumental staircase is now covered in dense residential blocks. To build that entrance, the Barcelona authorities would have to demolish 2 enormous apartment blocks and forcibly evict around 3,000 people from their homes. The residents are furious. They've banded together into associations, hired lawyers, and started filing lawsuits. And their central argument cuts right to the heart of it. They claim Gaudí never drew that staircase at all, that the blueprints the project's current leadership keeps pointing to are later inventions dreamed up by his students. What's more, they say Gaudí himself signed documents during his lifetime agreeing to limit the church's footprint. On the other side stands the Sagrada's leadership, waving plans from 1916 and saying, in effect, "We're sorry, but this bridge was conceived by a genius, and we are obligated to bring it to life." It's a conflict with no good answer. If the staircase is never built, the church is left permanently with a severed main entrance, incomplete by design. If it is built, it becomes an urban planning tragedy for thousands of families. The court battles are unfolding right now, as you watch this. And this brings us to the deepest question hanging over this entire project. We reconstructed part of the blueprints using math. We swapped the original stone for Scottish granite. We carved it with lasers and CNC machines. We laced it together with aerospace steel cables. The building has elevators, powerful climate control, and LED lighting. So, is this still Gaudí? There's a famous paradox in philosophy, the ship of Theseus. If you replace every plank in an old ship one by one until none of the original wood remains, is it still the same ship? Plenty of architectural historians argue that the modern Sagrada is no longer Gaudí's project at all. It's a high-tech interpretation by present-day engineers. Their case goes like this. Gaudí was a genius of improvisation. He changed the design every single day, right there on the site, watching how the light fell, how the stone settled into place. And what did we do? We took his rough sketches, locked them inside rigid algorithms, and mechanically printed them out at full scale, soullessly, one-to-one. But the people who've actually been building it for the last 40 years see it differently. They say Gaudí didn't just design a building, he designed a system. He left behind not a picture, but a strand of DNA, a genetic code. And like any code, it can be read and rerun with the tools of a new era. The Sagrada Família today is no longer just a church. It's a monumental paradox. A temple that peasants and craftsmen began carving by hand, with chisels, paid for by the donations of parishioners. And that robots, 3D printers, parametric modeling, and crowdfunding from millions of tourists are now bringing to a close. It's a monument not only to one obsessive, half-mad genius from the 19th century, it's a monument to human stubbornness, a wild, irrational proof that if an idea is powerful enough, if it infects the minds of generation after generation, it can outlast wars, fires, decades of empty coffers, and the complete upending of the world around it. And even when part of the source code was lost to the flames forever, humanity still found a way to finish writing the program. So when you finally make it to Barcelona, When you step through those doors and stand inside, when you tilt your head back and see that impossible forest of stone flooded with otherworldly light pouring through the dizzying geometry of the stained glass. Just remember this story. You're not only looking at beautiful architecture, you're looking at a century and a half of impossible engineering magic that, against all odds, became real.